Are life-permitting values for the constants of physics incredibly unlikely? This is the fine-tuning problem. And one popular explanation is the multiverse, the idea that our universe is just one of many, and we happen to live in the rare one that permits life. But recently, philosopher Philip Goff, writing in Scientific American, accused physicists of committing a logical blunder when they appeal to the multiverse to solve this problem. He claims it's an example of the inverse gambler's fallacy. That's a serious charge because when physicists were surveyed about fine-tuning, the multiverse came out as their second most preferred answer, just behind brute facts that need no explanation and way ahead of Goff's own favoured explanation, an intelligent designer. That finished last. In this film, we're not going to go into the scientific evidence for or against the multiverse or for or against fine-tuning. You can find that in Chapter 10 of our book, Battle of the Big Bang. Instead, we'll hear from philosophers who defend physicists against Goff's allegation. We'll review his arguments as presented on the Capturing Christianity YouTube channel, and we'll ask whether it's really Goff, not the multiverse, that's falling into error. But before we can assess this charge, we need to understand the alleged mistake itself. To do that, we need to know, what is the gambler's fallacy?
The gambler's fallacy, suppose you're playing a dice game, no double six has been rolled for a while, and you think, oh, well, now the next throw is more likely to be a double six. That's a mistake. That's the gambler's fallacy.
This is a fallacy because they're not taking into account the fact that what happens next is probabilistically independent of what's happened before.
So what's the inverse gambler's fallacy?
Right. So imagine you've just showed up to a dice game and a double six is rolled, and you think, oh, well, there must have been lots of other rolls earlier. Also a mistake. That's the inverse gambler's fallacy.
So whereas the gambler's fallacy assumes that a remarkable outcome will happen because there have been many opportunities for some outcome of that type, the inverse gambler's fallacy does the opposite. So it takes the observation of something that's remarkable and infers from that there must have been many opportunities for it to happen.
So was Goff right to say in his Scientific American article that whilst many physicists support the multiverse, experts in the mathematics of probability have identified the inference from the fine-tuning to the multiverse as an instance of fallacious reasoning?
It would be quite surprising if this collection of people with PhDs in physics who are all well-trained in mathematics were systematically committing a mathematical error. And so what I would say is it's not an accurate representation of what's going on. Everyone who's looked at it, I don't think anyone would disagree that the inverse gambler's fallacy is a fallacy. That's not the issue, right? Yes, it would be a mistake, right? The question is whether that mistake is being committed in the case of the people who think the multiverse would explain cosmic fine-tuning for life. And then there is not wide agreement on that.
So the issue I have is that identified is a success verb. So it implies that there really is a mistake. I don't think there is a mistake. I think there really is a good argument for the multiverse.
When he says experts in the mathematics of probability, that makes it sound like the issue is a clear-cut, objective, demonstrable thing. That's what most people think of when they think of mathematics. But we're not talking about the mathematics of probability. We're talking about the philosophy of probability. Right. We're talking about issues in epistemology and scientific reasoning, and it's not cut and dry there, right?
My assessment of the state of the literature concerning whether inferences from fine-tuning to the multiverse commit the inverse gambler's fallacy is that there is a lot of debate about this. So there are many objections that have been raised against thinking that this sort of inference to the multiverse is fallacious. There are also some defenders. So there's nothing like a consensus that this is, in fact, a fallacious inference from fine-tuning to the multiverse.
Another point that Goff makes in his article is that physicists have discovered that the universe is fine-tuned for life, and this cries out for some special explanation. But our poll implied that many physicists are skeptical of this. But the second most popular answer was the multiverse. So are those physicists making the inverse gambler's fallacy? Or is Goff making the why me fallacy?
Very often the question, why me? Okay, very often that is a bad question. I've thought about this for a long time. So one particular incident actually was a coworker named Karen. There was an earthquake in Yerevan, Armenia. I think this was 1988, and it killed about 40 or 50,000 people. It was really gigantic news at the time. And there was a story about a family that survived the earthquake. Somehow they were in the right place to survive it. And my friend Karen said, it's a miracle. And I said, well, Karen, um, 50,000 people died. There are so many people in that area. It's really not that improbable that someone somewhere survived that earthquake. And she said, well, okay, but it's a miracle that they survived. And I said, well, Karen, you don't know anything about them, but that they survived, right? The only way to pick them out is as the survivors. What you're really saying is it's a miracle that the survivors survived. And that's not a miracle. That's just true by definition. And then she called me an asshole.
So we couldn't have observed the universe with the wrong constants, but we could have observed some other universe that does have the right constants. So it's like being in a casino and you're asleep and you only get woken up if a 666 is thrown, right? Maybe the cheers wake you up. And so suddenly you are woken up, you observe a 666. Does that make it more likely that there have been lots of other throws that you've slept through? Yes, it does.
But one response I like to the inverse gambler's fallacy charge points out that in standard cases of the inverse gambler's fallacy, we know that there's probabilistic independence between the remarkable event and the many opportunities for that type of event. However, in the multiverse case, we don't know that our fine-tuning evidence is probabilistically independent of the multiverse hypothesis. And so these cases are crucially disanalogous in a way that prevents the inverse gambler's fallacy charge from sticking.
In his paper on the inverse gambler's fallacy, Neil Manson focuses on the case of 84-year-old Mary Ann Wakefield, who made the news by winning a car after sinking a hole-in-one during a pre-football game contest.
Oh my gosh.
Whenever I see anything on video, I automatically think, well, what's the process by which I came to see this? Because I know people are trying to get my attention, and there are all sorts of things out in the world that are attempting to get your attention. So when I saw this clip, I thought, oh, this clip of this kindly elderly woman, it made the national news in the United States. She won a car. What went on behind it? So I happen to have local insight. I called the automobile dealership here, and I asked them, how long have you been running that contest? And they said, about 4 years before. So a total of about 80 games. All right. So up to that point, there were 80 chances for this event to happen. Of course, that doesn't mean that when she was standing there that those other attempts have any effect on what she's going to do. But I thought it might put what I was observing in context. We observe these things that are just seem astoundingly improbable. And you might think, and this is the multiverse explanation, well, if there were a whole bunch of universes, of course, there would be a lot of chances for there to be a universe that's just right for life. And then just like I'm not going to see on my television show a whole bunch of video clips of people missing their putts for a car, because that's not very interesting. We're not going to see universes where things are not just right for life. So we've got a selection effect, right? We've got something that controls our observations, and that's our explanation for why we observe a universe that's fine-tuned for life. You're changing the question a little bit from why is the universe fine-tuned for life to why do we observe a fine-tuned universe? Just like I might change the question from why did Mary Ann Wakefield, that was the nice old woman in the video clip of the putting, why did she make that putt to why am I observing somebody make the putt?
In fact, we can make the argument that empirical science shows this sort of reasoning is not fallacious by considering two people in the past who might have argued over whether the Earth's location is finely tuned and whether this would be evidence for planets beyond our solar system, or as an instance of the inverse gambler's fallacy.
So one of them predicts that if our planet turns out to be fine-tuned, then that is more likely that we'll observe many planets. The other one predicts that if we observe our planet to be fine-tuned, then it's not more likely that there will be many planets. The existence of fine-tuned evidence for our planet would provide no reason to think there are many planets. But then the evidence comes in. We learn that our planet is fine-tuned. And then we look out into space and we find out, indeed, there are many planets. So this is the case where the proponent of the inverse gambler's fallacy made a prediction that turned out to be false. And the proponent of thinking that we can reason from fine-tuning evidence to many opportunities for the fine-tuning conditions to arise turned out to be correct. So I think that our planetary evidence provides reason to think that the inverse gambler's fallacy is mistaken, both in the planetary case and in the case of our universe.
The fine-tuning argument can be compared to winning the lottery. Many lottery winners do attribute their luck to intervention from God. Would Goff think they are right to do so?
We imagine, so there's 1 million tickets, one of them will be drawn as the winner, but we don't know how many tickets have been sold, right? And you don't know whether the winner would have been a ticket that's sold, right? So if no tickets are sold, no chance of someone winning. If all the tickets are sold, guaranteed someone will win. So when you learn that somebody has won, that means it's more likely that more tickets were sold.
So now we've laid out the groundwork, let's take a look at how Goff sets out his case in his Capturing Christianity YouTube video.
I'm walking through a park and I come across a monkey typing on a typewriter. I look over the monkey's shoulder and it's typing perfect English. It's just finished typing Hamlet, right? I think something odd here. Something's going on here. Maybe it's a robot. Maybe it's a specially trained monkey. Maybe it's a rigged typewriter or something. Now, here's what it would not be good to infer, right? It wouldn't be good to infer to say, oh, well, there must be a huge multiverse, because if there's a big enough multiverse with, enough variety in it, then there's going to be countless monkeys typing on typewriters somewhere in the multiverse. And if there's enough of them, then statistically, there's going to be some of them that end up typing out Hamlet.
So he's assuming that we only get to observe this monkey, right? He's assuming that there's this one monkey that we're allowed to see. If that's the case, then yeah, that's right. We can't make any inferences about other monkeys. But the analogous case would be something like, imagine there are millions of monkeys, and imagine we ask God, take me to any monkey there might be that's just written Hamlet. And God does, and we see a monkey that's just written Hamlet. Can we conclude that there are lots of monkeys? Yes, because the more monkeys there are, the more likely it is that one of them will write Hamlet.
In Goff's scenario, you're walking along, and you might not have been observing any monkey at all right? But you stumble across a monkey, and gosh, it happens to be typing perfect English. That's really weird. In the case of cosmic fine tuning, it's not like we could have existed in another kind of universe, right? It's not like we could have existed in a life-forbidding universe. By definition, that's impossible. So I couldn't have failed to observe a life-permitting universe, but I certainly could have failed to observe a monkey, and I could have failed to observe a monkey typing perfect English.
The presence of the selection effect means we don't have to explain why we are in a fine-tuned universe, because in some sense we couldn't have been in any other universe. You look back on your Richard Dawkins in The God Delusion, he says that, but something like that. But that's what everybody says. And that seems to make some kind of sense. But the great thing about having a Bayes theorem available is we don't have to trade in our intuitions of what seems to make sense, right? We can look at the question is, does this how does this change the Bayesian calculation? And I've never seen a satisfying account of why it would make a difference.
He says, Bayes' theorem tells us that it's irrelevant, right? Whether there are many other chances or not. Bayes' theorem doesn't tell us anything about that. We humans, right, doing scientific inference, have to make judgments of relevance or not. So don't say it's mathematical and Bayes' theorem settles the issue. Bayes' theorem says that if the thing you're trying to explain is why is someone alive, you get a certain answer. Bayes' theorem tells you if the thing you're trying to explain is why am I alive, you get a different answer. Bayes' theorem does not tell you which of those two things is the thing that needs to be explained.
Bayes' theorem is a way of working out how likely some hypothesis is given new evidence. And so Goff is saying, look, we can just appeal to Bayes' theorem here. We don't need to rely on intuitions. But the problem is, one of the inputs to Bayes' theorem is, what's the probability of the evidence given the hypothesis? That doesn't come out of Bayes' theorem, that goes into Bayes' theorem. So we have to agree on that if we're going to use Bayes' theorem. But that's where the disagreement is. The disagreement is about what is the probability of the evidence given the hypothesis.
The dividing matter is whether there's a relation of probabilistic support that holds between our fine-tuning evidence and the multiverse. And that's something that is not settled by Bayes' theorem. There's a virtue of not having fundamental coincidences baked into your hypotheses about the nature of reality. Now, the single universe hypothesis doesn't automatically have a coincidence in its perspective on reality. But once we get our fine-tuning evidence, it does look like the single universe has to posit, the single universe hypothesis has to posit a coincidence between the conditions that life requires and the conditions that are in fact obtained. On the other hand, once we get our fine-tuning evidence, the multiverse hypothesis looks like it doesn't have a coincidence baked into its perspective on reality. So it doesn't require that there be a massive coincidence between the conditions for life and the conditions that actually obtain. And so, according to this account, we get a boost to the multiverse hypothesis from our fine-tuning evidence, because our fine-tuning evidence results in the fine-tuning the multiverse hypothesis having a theoretical virtue which the single universe hypothesis lacks.
The Jane analogy, right? So Jane, this is my mention. Jane was conceived through IVF, and she finds out as a grown woman that the doctor who fertilized the egg that became the embryo that became her was having a nervous breakdown, and so the doctor rolled dice to see whether she was going to fertilize the egg. She was only going to fertilize the egg if it was double six, or maybe if it was 5 6s, if you want to make it more improbable. Right, but fortunately, the right numbers came up, and she fertilized the egg, and Jane came into existence. And I want to say, as part of the story, that Jane knows that the doctor subsequently had therapy, and that doctor only did it that once. Right. Now, so there's a sort of selection effect here, right? Because Jane couldn't have found out about a roll that wasn't a double six, right? Because if it wasn't a double six, the doctor wouldn't have fertilized the egg. Jane wouldn't have existed. So it had to be a double six. So there's a sort of so just as we couldn't have observed a non-fine-tuned universe, Jane couldn't have found out that it was not the case that a double six, that some other number than the double six was rolled. So here's the question. Does Jane have evidence for what I'm going to call the many doctors hypothesis? That there are many IVF doctors rolling dice to decide whether to fertilize eggs? I want to say obviously not, right? All she has evidence about is that her conception was brought about in this way by this doctor rolling dice. That whether or not there are other doctors rolling dice to decide whether to fertilize eggs has absolutely no bearing on that. It doesn't make her evidence about her conception any more likely, right? So I want to say, similarly, the selection effect in the case fine-tuning doesn't make a difference.
He does mention the crucial assumption that the doctor only does it once, right? So if instead the doctor made all his decisions about going ahead with the IVF only if the 66 was rolled and we were the product of one of those, we think, well, yes, it is more likely that there were lots of these cases. The more of these cases there are, the more likely it is that there is some human that's caused to exist by this process. And that, again, that's what I think is the situation with multiverse. There's no reason to think we have to be in this universe. We could have been in a different universe. So that's like there being lots of trials.
How do babies normally get conceived? Well, a sperm fertilizes an egg.
Right.
So suppose I'm Jane and I found out I wasn't born by IVF, I was born by natural means, and I learn a little bit about how this actually works, and I find out that the probability of a sperm fertilizing an egg is 1 in a billion. So now I want to guess. I come up with the many sperm hypothesis. Well, the only way that I could have ever existed is if there were many sperm, because then I could overcome that low probability. Wouldn't I be justified in coming that? And isn't that actually what happens?
Yes, I agree. And if you believe that in order for you to exist, as opposed to some other child with the same name but a different genetic makeup, in order for you to exist, at a minimum, that very sperm and that very egg had to get together, right? Then right there, the probability of your existing is astronomically low, right? And then you go back in time and say, well, that sperm and that egg would have to have come from my parents, and that same thing would apply, right? It's all astronomically low. So it's incredibly improbable that I exist. And I would say yes. And what's your point?
Yeah, I think that's a really good point. That does strike me as analogous to the planetary case, where we may have started out in a position of ignorance about whether or not there was a big ensemble of ways for a remarkable outcome to occur. And then lo and behold, we find out that there is such an ensemble. And that seems to be predicted by the hypothesis that an ensemble would help explain the remarkable outcome. In this case, Jane's creation. In the planetary case, the existence of a fine-tuned planet, and in the multiverse case, the existence of a fine-tuned universe. So I think as we come up with more cases of this type, like the nice one you just gave, that provides further evidence that there's something wrong with the inverse Gamblish fallacy.
Renowned philosopher of physics Tim Maudlin, who I'm a huge fan of, but I find it very, very, very aggressive discussing. I was like, oh my God, he hates me. But people say he's always like that. But anyway, he's a great philosopher. But what he and many others have wanted to say is, well, what Jane could have evidence for is that that her doctor rolled many times to decide whether to go ahead with her conception. I've had this quite a few times, right? Now, if it was, say, indeterminate how many times her doctor had rolled dice to see whether to fertilize the egg, then I agree she would indeed have evidence that the doctor had rolled a dice many times, because that would make her conception more likely, which is her evidence that her conception came about. But that's not analogous to the real world fine-tuning case, right? That would be analogous to a universe where a situation where our universe had many shots at being fine-tuned. And let's say there's the guardian of the galaxy was waiting to see if it got fine-tuned and then giving it the go-ahead to continue, right? And that's a kind of weird design hypothesis. Right? That's not the standard design. The standard multiverse hypothesis is that our universe just had one shot of fine-tuning it, of getting, the numbers fine-tuned or otherwise, but there are all these other universes that also had a shot, right?
So here Goff just ignores the fact that scientists have proposed models of the multiverse that are exactly like the ones he suggests would solve the problem. Here's an example from Alexander, Cormack and Gleiser. Roger Penrose has speculated that his own cyclic model might achieve this.
One possibility might be that in the eons of CCC, these numbers have different values. And there's this thing called the anthropic principle, which might say, well, we're only in that eon where these numbers have exactly the right values, where life could come about. And if you change monkey with these numbers too much, life wouldn't happen. Now, I think that's a bit of a dangerous argument because we have no idea what life would be like, even with these numbers. We don't know enough about life to know that it would never necessarily come about with the numbers that we see. We don't know enough about it to say it wouldn't come about with other numbers. So I think it's a dangerous argument to use. There may be another reason why they have these values, which is purely mathematical. We just don't know. So there are big questions here, which are interesting to talk about, but I don't think you can make any big conclusion from them.
But it's hard to see why it matters if there's one universe cycling through eons or many universes, as long as there are multiple chances for life to exist.
On the one hand, there's a kind of philosopher's version of a multiverse hypothesis, which is where you just have all these independent realities alongside each other, or something like this. Kind of reminds me of the TV show Sliders when I used to be on. But the physicist version of the multiverse is nothing like that. The physicist version of the multiverse is just where there's one very, very large physical reality, and different proper parts of that physical reality look like the visible universe. And then those regions that look like the visible universe, that's what we call universes. In this sense, there's one large physical reality, just like there's one doctor. And that one large physical reality has multiple chances to come up with regions that allow for the existence of human beings.
We say it's incredible that our universe is fine-tuned for life. I say, well, how are you picking out our universe except as the universe in which we living beings are asking this question? And of course, if that's the question, we couldn't fail to be in a universe that permits the existence of life. So you've got to have some, for this problem to be motivated at all, there has to be some way to identify, to pick out a universe, the thing that they're calling this universe. There has to be a way to pick it out, aside from just being the one that we are in. Otherwise, the problem falls apart. I just don't see any motivation for it.
Right, so if we just knew, had overwhelming scientific evidence, independent of fine-tuning, crucially, that we were in this huge multiverse and most of the universes were not fine-tuned, and a very, very, very small number, including our own, were, then I think that would undermine the argument for design. Now you might think, well, don't we have evidence? So that what they get right is if we did have independent scientific evidence of multiverse, that would undermine the fine-tuning argument for design.
Indeed, one of the leading theories for how galaxies form is inflation, which seems to predict a multiverse, and some scientists claim we have evidence for it.
The type of inflation, that the Planck data say happen, strongly favour flat potentials. So a scalar field evolving in a flat potential, and then inflation is eternal. So the Planck data say that inflation is eternal. The simplest models would have an eternally inflating universe.
And Planck favours those models.
Yeah.
So when I hear all the time on TV, there's no evidence for a multiverse, what you're telling me seems to imply there is.
Yeah, and if inflation is eternal, then you have a multiverse. And that's why I say that I think this is the most important result from Planck. We're sort of being pushed towards now experimentally in the direction of a multiverse.
Although if you want to hear from both sides of the debate about inflation, do check out our book, Battle of the Big Bang. So whilst the case for an inflationary multiverse is far from definitive, it certainly looks better than the argument for an immaterial mind.
Take the evidence to be our universe is fine-tuned. We should take our evidence to be this universe is fine-tuned. But it is incredibly unlikely that this universe is fine-tuned on landscape eternal inflation, right? On landscape eternal inflation, as they describe it, there are these random processes that fix the local physics in the different bubbles, and very few an incredibly small number of them are fine-tuned. It's really improbable. So on that very theory, it is incredibly improbable that our universe, that this universe will be fine-tuned, and that is our evidence. And so our evidence massively disconfirms landscape eternal in theory.
On the assumption we can only observe this universe, so granting Goff's assumption, what might our observations of this universe tell us about other universes? Nothing, because we've just kind of nailed onto this universe. So you won't get disconfirmation. You won't get confirmation either. It will just be completely neutral. It won't change your degree of belief in any multiverses. So I don't know how he gets to the conclusion that it disconfirms multiverse.
Suppose you had a huge line of people that each of whom drew a lottery ticket. And now, even though the results of the lottery are not yet revealed to you, they are revealed to a marksman. And this marksman kills everyone that didn't win. Now you're the one person left over. And you're wondering, why was I the person that wasn't killed? Well, the only explanation here, the only reason you could be the person that wasn't killed, is because you won the lottery, right? So likewise with the inflationary multiverse, you're only going to make the kinds of observations that occur in universes where observers are possible, right? So the kinds of observations that you could expect are going to be constrained by the fact that you inhabit the universe that you do.
But the fine-tuning argument is predicated on the claim that the constants of nature could easily have been different. Why believe this? Well, one justification deployed is the landscape of string theory, which has different compactifications for the extra dimensions, give different values for the constants of nature. Indeed, this is how Christian philosopher William Lane Craig ruled out necessity as an explanation for the constants of nature in his debate with Sean Carroll.
We may argue, 1, the fine-tuning of the universe is due to either physical necessity, chance, or design. 2, it is not due to physical necessity or chance. 3, therefore, it is due to design. Consider then the first alternative, physical necessity. For example, the most promising candidate for a theory of everything to date, superstring theory or M theory, allows a cosmic landscape of around 10 to the 500th power different universes governed by the present laws of nature, so that it does nothing to render the observed values of the constants and quantities physically necessary.
But if the string landscape is ruled out, then where is the justification for the claim that the constants of nature could be different, something essential for the fine-tuning argument to work? More broadly, we could say that if the constants of nature can be different, then a multiverse will solve the problem. If they can't, then the multiverse won't solve the problem. But then I think we can say there is no fine-tuning problem after all. Without some mechanism to allow the constants to vary, how can we possibly say that the values are unlikely? Perhaps that's why the single most popular answer to fine-tuning given by professional physicists when surveyed on the topic was neither the multiverse nor God, but rather they are brute facts that need no special explanation.